Gamut is an innovative programming by demonstration tool for making games, simulations, and educational software. Gamut's goal is to allow the developer to express the objects and conditions on which a behavior depends. In this Qbert-like video game, I would like to make the character jump to the block which the player clicks on. First, to show where the tops of the blocks are located and which paths the character can follow, I will draw a circle over each cube and connect the circles with lines. These circles and lines are drawn as guide objects, so that the player will not be able to see them when he plays the game. Gamut uses icons to represent the player's mouse actions. To click on a cube, I will drop a click icon onto the screen. Gamut uses a new technique to demonstrate examples. The developer creates behavior by correcting Gamut's mistakes by pushing either the Do Something or Stop That button. I want the character to move, so I push the Do Something button. When I move the character, Gamut leaves a temporal ghost behind. Gamut lets me provide hints to point out significant objects. Here I highlight the line connected to the character to show that it is being followed. In my second example, I drop a click icon onto another position. Gamut has not yet learned the proper behavior and moves the character to the wrong place. I can correct the behavior by selecting the character and pressing Stop That. Stop That provides an understandable way to teach the system negative examples. I then move the character into the correct position. When I press the Done button, Gamut does not know which line the character is supposed to follow, and so it asks a question. I will answer the question by highlighting the click icon and the guide object circle. Gamut will incorporate these hints in order to resolve its question. At this point, the character will move as I intend. I can continue to augment this behavior by showing more examples. I have added markers on each of the squares which I would like the character to collect when it jumps on them. I move the character by using the click icon. I then press Do Something and delete the square that the character has landed on. I will highlight Gbert to show that it is important. Now the behavior will delete the markers as it should. Gamut can also learn some numerical operations, such as counting a number of objects, and can learn to create objects as well. In this next demonstration, I will make a monster move randomly. First, I will draw 4 arrows to show the directions I want the monster to move. I will place the arrows into a deck object which can hold a set of objects. I will use another arrow for the monster to follow and a timer to make the monster move automatically. I press the tick button on the timer and press Do Something to demonstrate the first example. Then, I shuffle the deck and move the arrow to have its tail in the center of the monster and point in the same direction the deck shows. I will highlight the monster and the deck to show that they determine the line's location. When the line's path is clear, I would like the monster to move to the end of the line. Pressing the tick button, I select a direction that is clear. Press Do Something and move the monster to the end of the line. I highlight the line and press Done. Resetting the example, I select the case where the line passes through a wall. I select the monster and press Stop That. When Gamut asks why the behavior of the monster has changed, I highlight the wall and the line to show that they intersect. The monster will now move randomly, but not pass through walls. Gamut has been used to create a variety of applications. Gamut can build complex behaviors without requiring the developer to hand-edit code. Gamut has also been tested in a small user study. It showed that non-programmers can learn to use Gamut effectively in a short period of time.